So you may have wondered why is the Helmholtz function called delta A? Why A? Well, it's because the German word for work is Arbeit. Okay, and so there must be some relationship between delta A and work. So let's look at the differential for A. dA is equal to minus SDT minus PdV, and it's only equal. Of course, it's less than this if it's irreversible, but if it's reversible, it's equal. And let's throw on that in general, we'll also have to worry about non-PV work. Okay, electrical or surface tension or whatnot. Okay, so if we're working reversibly, which we must be if this is an equal sign and not a less than sign, then this is equal to minus P external dV, or we could say it's equal to work. That is expansion work. So we could call this dWPV. It's the term for PV work. And then we have this other term for non-PV work. And we could just group these together, and we could say the total work, PV work and non-PV work, that's a horrible total. The total work plus SDT is equal to dA. Now if we integrate both sides and we impose constant t before we do that, so at constant t this term goes to 0, we're going to get the following. We're going to get the delta A at constant t is equal to the work total. Not just expansion work, but all the work we could do. And remember, we get more work when we do things reversibly. And this is implying, the equal sign here is implying that we are working reversibly. So we say this is the maximum total work that we can get is given by the Helmholtz function. Now you might wonder if there's some relationship between delta G and work, and there is. Let's do the same analysis for dG. So we've got minus SDT, we've got VDP, and then we have the possibility of other types of work besides expansion work. All right, now let's just imagine what would happen if we impose constant T and P. Okay, so maybe we're working in an open vessel, so it's constant P, and maybe it's a beaker that's inside a thermostated bath, so we're constant T. Well, in that case, we could get rid of this term, and we can see dG is equal to the non-PV work. So if we just integrate this, we get delta G at constant T and P is equal to the non-PV work. And once again, this is saying that we're working reversibly. So this is the maximum non-PV work. Okay, so what's an example of this? Well, if we wanted to calculate the maximum amount of electrical work we could get out of a fuel cell or battery, we would be using delta G.